Okay, guys, and today our topic is if you you have you have get any you got any system, then you have to check whether this is a LTI system or not. Say you given x1 t equal to y1 t, x2 t, its output is y2 t, x3 t to the y3 t. So if the system is given, then you have to check whereas this system, because a system, if you put x1, if you put x2, if you put x3, then you simultaneously get u1, sorry, y1, this is y2, and this is y3. But you have to, this is the system, but you have to examine whether this system is LTI or not, or not. So what are the steps? First step is that select any one of above. Then it can be seen that the algebraic sum of the incoming current that will be equal to 0. Okay, so that means that okay, then express guys, please note it down because these are the very important topic for signal system, and you know signal system is very important for your gate also. So we have to know the some basics and basic critical basic, and simultaneously we have to cover the syllabus also. So express any one input of, but in case of the internal fault, in terms of or in forms of other input. So if it is an internal fault, then the sum is not zero. Sum of the incoming current is not equal to zero because there must have some fault that will be appeared from the masses. Input. So first is you can say this is your x1, x2, x3. So take any one. Say I am taking x1 input, and we have to express this x2, x3 in the term of x1. So x2 in terms of x1 and other things. You may apply amplitude modulation. You may this is time shift, anything. Then you can find the y. If this is the same, then it will be the LTI. Otherwise, this system is not. This is linear, but this is not time invariant. This is time variant. Say you may apply amplitude scaling. Amplitude scaling. Okay. You may apply inversion. You may apply time shifting. Time shifting means here to here, here to here, etc. That is time shifting. Here you may apply addition and subtraction. Our motto is same in both the cases. That is, we need to of two signal. Okay, but you can't apply, means you avoid, but we need to avoid. We need to avoid one modulus. We need to emphasize on this section only. X square, x cube, this type of terms. Okay. So if I perform this, then we can we can verify whether this system is LTI or not. Say we are going for an example. You can take an example, then you can understand this thing. First one is, that is for an example, for if this type of statement is given, then no need to no need to check for the linearity. We need to check whether the system is invariant or not invariant, means time invariant or not. Say this is x1, you have given, this is discrete function, it is given, you can realize this signal, this is -1, this is 2, here it is given, this is 1. Okay, so corresponding output output will be y1 in equal to 1, that is 2, that is 1, that is 0, that is 1. Output, if I got, this is x2 in equal to, if this is the another input, that is 1, that is -1, that is -1. Okay, that is output is given y2n. What is the value of y2n? Y2n is value is that -1, 1, 0, 2. Okay, and your x3n equal to 0, 1, 0, 1. This is 1 also, and output is y3n equal to, that is 1, that is 2, that is 1. Okay. Okay, this is your uh, this is your statement, but we have to check whether this system is LTI or not. So, yes, yes, tell me. Yes, tell me. Okay, so you can see, first we have to first, what are the checking process? Select any one of above, then express any one input in the terms or in the forms of other input. So you have to choose any one of this, then you have to express other in the terms of this. Say I am choosing, choosing this is x1. Okay, so if I got this x1 in, then we have to express this x2n and x3n in the terms of this x1n. If it is possible, then okay, then we have to verify whether the corresponding terms of y is also equal or not. If this is equal, so this is the LTI system. If this is not equal, then it is not the LTI system. So this is your example. I will show you how could I do this. Okay. First, you can get, and which operation is allowed? This operation is allowed. You can get amplitude scaling, inversion, time shifting, addition and subtraction, but you can't take any modulus, x3 x cube type, any formation you can't take. Okay, so your uh, so you can see that is your x1n. So that is your x1n. You can see it is given, that is 1, -1, that is 2, and that is 1. So you can see this, but we have to express other x2, x3, and x2 and x3 in terms of x1. So you can see x2 is, what is x2? X2n is x to n is, that is 1 minus 1, and that is minus 1. Here in this portion, x3 also in equal to 0, 1, 1. So if we have to take either x3 or x2 in if I select it, then in terms of this. So how could we do this? Just think of it. Say first we can take an operation x1 shifting operation, x1 n minus 1. N minus 1 means this is a shift over there. So if this is the 2, it will shift here, it will shift here, so it will be this. So we can say this is 0, this is 1, this is 2, this is 1. So this arrow will be shift over here, this arrow will be shifted over here, because this is minus 1, it will shift over there. If, and that's why here is nothing, that's why we put 0. If we go for x2, that is again shift minus 1, what happens? It will x2, it will shift over here, so it will, you get this one, and as this is this minus 1 also there, that is minus 1, that is minus 1, and this is, you have to put 0, or you can't put also 0, just like this. So x1 minus 1, x2 minus 1. If we add this thing, then what happens? x1 plus x2. If you add this, just x1 in plus x2 in plus x1 in minus 1, sorry, this is plus x2 in minus 1. If you add this, what will be the result? What will be the result? You just arrange it, then you can find it. Uh, if you arrange this, you can find that is x1, x1 in is the minus 1, that is 2, that is 1. Okay, here is this x2 in, it is 1, it is minus 1. I put all this zero position over there. I put all this zero position over there, so that you can understand this, and you can put this x1 in minus 1, that is minus 1, that is 2, that is 1, 0 is here. x2 n minus 1, x2 n minus 1, that is x2 n minus 1. Here is the minus 1, minus 1, minus 1. So this is 1, minus 1, minus 1, and you can put this all over here, 0, 0 over here, 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 0, 0, so that you can understand. Now if I add this, we can find, look, here this is 0, so I put 0. This is minus 1 plus 1, this is minus 1 and plus 1. These things yields you 0, and this is the origin position. This is 2 minus 1, so plus 1, plus 1 up to this, this is plus 1, plus 1 and minus 1, this is 0, and this is 1, so only plus 1 is alive. So here is, it will be the next position. So minus 1 plus 1, 0, 2 minus 1. So this is coming 2 minus 1, this is plus 1, and here only 1 and 1 there. So you can get, this is 2 and this is 0. So this meanings is that, it means that okay, another xn should be okay, another X minus n is, sorry, this is the minus n. This is, look, this is your minus n. So you have to put this is minus n. So this is 110 and this is 110. So this is also 11. This is also 0, not 2. So you get 110 and sorry 11. So 00 is there, 00 is there. You can write it or you don't write it. But for your simplicity, for your uh, for your this purpose origin, you can write it or you don't write this. So this is your equation. So you can see the output of this terminal is here. Output of this terminal here. But you can see this is another input. You can see if you watch this, if you watch this, look, if you watch this, you can see that is x3n is the 0 1 and here is 1. X3n is 0 1 and 1. This arrow is for upper arrow, this is not here. This means 0 1 1, where is the 1 is the initial point. Is that the same? Guys, you can see, is that same with the x3? Yes, it is same. That's why we can write this value is x3n. Guys, is that same? Anyone can say? If you don't examine with your own eye, then it will not fruitful to your study, because just I am telling you, but you don't verify. Look, xn is the 0, 1 and 1, and here we get 0, 1 and 1, and 1 is, here is the initial position, arrow is there. So is that same? Is that same or not? Is that same or not? Please tell
Yes,
me.
sir, same.
Okay, okay. Thank you. So it is same. So whatever we told in the statement, you can just remember this statement. Express any one of this input in the term or in the form of other input and select any one of this above. So this input, this x3 input, we can express in the term of this. So we can write this, we can write this. This is just equal to the x3n, x3n. So x3n is expressed in the x1 of n and x2 of n also. Okay. Now we can perform the first step. Then we have to check if it is a time invariant system or time variant system. If per each change of xt, then we get specific of yn, x1n for the y1n. So if I give x3n, then sorry, this is t, this is n, this is not equal. N is for the discrete and t is for the continuous. So if I put x3 n, then we have to must get y3 of n. If we don't get this, if I apply x3 n, then we get another term, say y dash term. This is not equal to this y3 term, then our system is not time invariant. It will be time variant. It is linear. They told that your system is linear. They first told it is given linear system. For the linear system, so your system is linear, but you have to know whether this system is exactly linear and time invariant or time variant. So we have to examine this. So you know that is x1 of n, x2 of n, x1 of n minus 1, x2 of n minus 1. We have to again add this, but its output, corresponding output is y1, output is y, sorry, x1 output is y1, x2 output is y2, and x1 n minus 1, its output should be y1 n minus 1, x2 n minus 1 output should be y2 n minus 1. So if I just write this y1n, because I have to write down the correspondence of this x. Just I do this here so that you can understand. Okay, so just remember this x, this output is just like x3n, just like x3n. Say this is x3n. So I am putting y1 of n corresponding output. We can put y2 of n corresponding output plus its corresponding should be y1 by n minus 1. Okay, and y2 of n minus 1, its correspondence its correspondence is that output, its correspondence is that its correspondence is that. So if I add this term of y1 y2 y1 n minus 1 y2 n minus 1, if I got this y3 of n, then it is okay. But if it is not okay, then it means x3 of n, it is not correct with this y3 of n. So then it will be your time variant system. So just add this, then we should get this thing. Just add this. So what will be the output? What will be the output value? Look, your output is just like given yn. So yn is, just write down your output. Just your output is 1, 2, minus 1, that is 0, that is 1. Okay, and where is the, yes, this is here, y2n, it is minus 1, and this is 1, this is 0, this is 2, and this is nothing is there. Okay, so y1 n minus 1 you have to put just like this. So this will be shifted, it will be shifted just like this. So this will be 1, I am writing the another color, that is 1, that is 2, that is minus 1, that is 0, that is 1, and you can put here. So it will be shifted just these things, it will shift it from here to here. And y, look, I am using the different colors so that you can understand. Look, this term will be just shifted. So look, this will be here. So this is minus 1, this is 1, this is 0, this is 2, this is 0, because nothing is there, you may put. Okay, so all origin are here. So if you add this, we have to examine where it is coming y3. So if you add this, you can find I am writing this over here. Look, 1 and minus 1 and 0. So first term is 0. Then 2 plus 1 means 3. 3 plus 1, this is 4. 4 minus 1 means 3. And origin is here. Arrow is here. Minus 1 plus 2. 1. 1 plus 1, that is 2. This term is over. 0, 2. 0, 2, and this is minus 1 means plus 1, and this is 0, so this is plus 1. Here 1, 0 and 2, so 1 and 2, that is 3. Here is 0, here is 0, here is 1, here is 0, so this is 1. So we got this term after summation. This is summation, sum. Okay, but we have to check whereas this term is equivalent to this to this y3 or not. What is your y3? What is your y3? You can see your y3 is here. Your y3 is, where is your y3? Y3 is here. Y3 of n, it is 0, 0, 1, minus 1, 1, 0. 0, 0, 1, minus 1, 1, 0, and 1 is, the first one is the origin. So no, this is y. This is not y3. This is not y3. This is sorry. This is not y3. Actually, this is the term which your y3 is here. Oh, it is going slip. Yes, your y3 is 1, 2 and 1. 1, 2 and 1. 2 is at that point. So your y3 is, but original your y3 is original, your y3 is, you can see here, it is written, this is 1, y3 is 1, 2 and 1, and 2 is the initial point. So that is 1, 2 and 1, that is initial point. Okay. So this is your y3, but this summation is not equal to this y3. But your x, if you apply the input x1, x2, x1, n minus 1, x2, n minus 1, if you add this, then it yields your x3, x3 of n. But corresponding of this input means it will give you y1 of n, y2 of n, y1 of n minus 1, y2 of n minus 1, because it's corresponding this, it will not produce y3 of n. Input will produce x3 of n, but does not produce y3 of n, because this this is not equal. Okay, here 3 is initial point, here 2 is initial point, and no terms are there, only 1 and 1. If you go for signal, if you want to draw this signal, then 1, 2, 3. So this is your 3, and this is your 2. So this is your 2. So 1, this is 2, this is 3, this is 4. So here is your 2. In one position there is 2, there is 1, there is 1. Again here is 3, and again here is 1. Okay, this is your signal, but here you can find your signal is just like this. Means 1, 1 is here, this is 2, 1, 2, here is, this is minus 1, minus 1, this is 1, and this is 1. So here is your signal. Is that same? No, is that not same? Because here is some 3 term, some 2 term, some 1 term is there. Here is nothing is there. So this is not equal. And that's why you can examine your system is not time invariant. This is time variant, because due to this, the other impulse are coming. So in this way, you can find whether this is a long, big system. You can find whether this is the LTI system or this is not a LTI system. Okay. So up to this, I think you can understand. If you have any queries, you may ask me. Then I am going for the static LTI system. So the previous system was not time invariant, it was time variant. If it is not time invariant, then you can easily call this is time variant. Okay. So next one is static LTI system. Static LTI system is that y, if you get some y of t that is multiplied with this constant, it not have any shifting property, means it not has any this type of property is not there. If something is there, then it is not static. This is shifting means you may shift here, you may shift here, or you may shift over here. So shifting means this is dynamic, this is not static. Static means you have to static over here, so that is the only function. You never transfer here, you never shift here. Okay. So this is the static, but static means it can up, it can down, etc. But your position should not be changed. Then it will say that is static LTI system. Okay. Say you are standing over there, you are standing at the at Tata station, you are always standing over there. If you move here and here, then you are dynamic. So this is called, then it will be called, no, this is not the static. Okay, uh, this is a simple example I give you so that you can understand. And then how could I examine this? Look, if we go for this is for also in the discrete function. This is simple terms for this. This is for the x. Okay. And how could I examine this? First, we have to go for the Laplace transform. If we go for the Laplace transform is not covered now, but just remember this. If we go for the Laplace transform, then we get the transfer function which is called s, and it will give you the, this t is converted in the time domain to the frequency domain, and then x will be going to the time domain to the frequency domain. That is, it is given as the f, and it means that is the ratio yt by yx. So that is the k, and k is the constant. And if we go for the constant term, k is the constant. And if I go for the again inverse Laplace, means again frequency domain to the time domain, then we get h of t, h of t. This is hs of t, and this is, if we go for the inverse Laplace transverse, and then we get h of t. H of t means k became constant is constant, and we get an impulse function. Any term, constant term, we get, if I go for inverse Laplace, then we can get impulse function. Impulse function. Impulse function. So this is the, so if I get this only one, this is only this situated over here, t equal to 0, where t equal to 0, then it will exist. If it is not equal to t, it is not equal to t, not exist. Okay, then it will 0. Because you can see this is 0, this is 0. But only t equal to 0, yes, this is a one pulse is there. Just like a one pulse is there. Just like a one pulse is there. But what is the static? This is the 0 position. So it is a static LTI system, because we get only a constant term. Just like this, if you go for this term yn equal to k kx of n, then if we go for Laplace transform of this, then what get, this is the z yz by xz equal to k. And if we go for the again inverse Laplace ILT, inverse Laplace transform, then we get again this form, that is x by n. Okay, so again we get an impulse function which is situated over here. Okay, and then we have to check whether, and now from you have to check, find out. So if first question is h of t, means h of t is given, u of t, whether this is static LTI or not. 2, that is h of n equal to u of n minus u of n minus 1. 3, that is h of n equal to u of n minus u of n minus 2. Just examine this term, whether this is static or not. If it is given h of t is the del of this t. Okay, so guys, just remember this thing. H of t is the u, means unit step function. Unit step function. Unit step function means there, if there is a 1, it will start from 0. It will start from t equal to 0. Here it is start from t. This is t, and it is going on. So it is start from 0 unit step, and it is going on. So what are the condition of static LTI? Condition of static LTI is that when it will pulse is exist when t equal to 0 exists, but when t not equal to 0, then pulse will be 0. So here you can see t is 0, it is exist, t is 1, it is also exist, t is 2, it is also exist, t is 3, and this is continuous function. And if not continuous, maybe discrete, it is also exist, also t equal to 1, t equal to 2, t equal to 3, and after the infinity. So is that a static LTI? No, because static means otherwise 0 it will 0. So it is not 0. Otherwise 0 it will 0. But not it is otherwise 0. 0 except other function 1 is 2 is this exists. But -1 -2 then it will only 0. But here positive side is 0. So it is not static, it is not static LTI system. Now in this case u of n unit step function, but it is a discrete. Here it is continuous, but here we draw the discrete unit step function. This is one, so this is one, this is step function, it is going on going on going on. Okay, unit step function, it is there, u of n is there. Okay, but u of -1 means this is the advancement, it is shifted to over here. So it will shifted to this one, -1 means it is shifted to the plus side. So it is there, it is there, nothing is there, nothing is there at the t equal to 0, nothing is there, nothing is there. So it is 0. So if I minus this term subtracted by this term, what happens? This all term will be, this all term will be nullified, but only this is blank, this is 0, and this is 1. So our this position will be given just only t equal to 0. Only t equal to 0. So guys, could you understand these things? So if I minus un minus un minus 1, then it will be shifted 1 and then minus all these things. So only this portion will be remain. Then portion will be remain. So this is the now we have to check whether this is static. Static means whether t equal to 0, only there something is exist. But when t is not 0, then it will become 0. Look, when the t is 0, yes, there only it is exist. But whether this t equal to 1, 2, 3, no, it is all are 0. Whether t is a -1, -2, -3, this is also 0. So it will satisfy these rules. So it is a static, yes, yes, this is a static thing. But same things, if we have just another one is shifted, so there is, look, there is one 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 there, that is u of n. But if I shift it to -2, n -2, then it will shift 1 2. Here it is started, so here it is started. So this portion is blank, this portion is blank. If I minus this term from this term, so it will also left 0 term and 1 term. This is 1, this is 0, this is 1, this is 2, this is 3, this is 0, this is 1, this is 2, this is 3. So it will just nullify this this term. So this is started from this 2, it will nullify this term. So we got this one, this 0, and this one, 0 and 1. So is that a static LTI? Static LTI state that if t equal to 0, they are only 1. If t equal to 0, they are only 1. But other side of 0, t equal to not equal to 0, then it will should be 0. But t equal to 1, that is a function. So it is not the static LTI. So this item is not static LTI. Here you can see that is a impulse function. Here you can see that is the impulse function. Impulse function means t equal to at the 0. T equal to t equal to something. Here is pulse, but other side it is not exist. But something is added or multiplied with this. So multiplied means if not only if there is one and delta means say there is a delta means there is a 3. So 3 is multiplied with this signal, it will be become 3. But now, even now, it is satisfied this rule. This is t equal to 0. Yes, t equal to 0, it is exist. But when t not equal to 0, then it will be 0. Yes, when the 1, when the 2 is there, this is 0, 0, 0. So this is 0. And this is minus 1, minus 2, minus 3. This is also 0. So it will also satisfy the static LTI condition. So it is also a static